Uh, Hello, welcome back to the stream. I'm back. Took a little break last week, but I'm back on my feet. So here we go. I'm Agent Ultra. If this is your first time watching, welcome to the stream. On this stream, I do basically Haskell stuff. I build things, and for the last little while, we've been building. We've been learning and building about wave function collapse, an algorithm for doing procedural texture generation, amongst other things. But we're focusing on the texture side of things. We're just at the point now where we have kind of a rough bit of we have the main algorithm kind of sort of done, we think. Like it's passing all the tests and the code's like, and we're just building the visualizer now so that we can see the output in like an SDL kind of application. We can visualize it, right? So that's what I got on the old to-do list here. And we're gonna get to it. Okay, so first things first, let's go to the code. Pop it open and get started. I'm gonna go to the app for kind of we're building the visualizer under here. Okay, and if I remember correctly from the last stream, we are at the point where we need to load the texture from at the SDL side of things into our library's texture format so that it can manipulate it and do the things it needs to do. That's what the item on our to-do list is, load texture. That's what we're going to do. Got to do get texture, which is get that data back out of our output texture from the algorithm. Put it into, this is going to be confusingly named because there are textures on both sides. But then we got to put it into like a texture on the SDL side in order to render it to the screen. And that's what we will do. So, yeah. This code is probably not gonna super be great here because we're doing some casting here. And, I mean, casting will be fine as long as we cast the right thing, the right type. But I gotta double check what size word is here. So I think the values, if I'm not mistaken, in the image format that we're using here are going to be 32 bytes with like the words packed in there, so that each channel. So it's going to be like 8 bytes for RGB and then the alpha. Yeah. So, might need a word 32 there, but otherwise I think that'll be fine. I don't think I have word 32 in scope. That comes from a place. Oh, brain. Data.org, of course. Right? Of course. Although I think I might want the foreign ones there, but there is one. Oh, data. Let's go. Do. Ooh, that's no good. The wiki's returning a 503. Ah. Yeah. We'll get to it. Hopefully Hackage is in town. That would be bad. It's not foreign pointer. Foreign C types. Because this is going to be coming from the C stuff, so CU, short, no. I think they're going to be unsigned. There we go. Unsigned and CU int. In other words, a word 32. Yeah, the pixel pointer is not going to be cool for that because peak element offset from that. We wanted to return a word there. Return CU int. Okay, now type checker cool. Okay, change pixel cast to CU int 32. Bang. Okay, so we get the pixel. We have that function, that's good. Okay, so we have the surface dimension. This is our input texture. Okay. Get the surface pixels from image surface. So that's the pixel pointer. We get a pointer to that. Then we sequence our getPixel function over that pointer, passing an x int for each int in up to that. I guess for hopefully for each pixel in the surface. And then we return WFC, that's our wave function collapse, texture from list, from integral image width to pixel. So that might be our load function right there. Actually, that might already be done for the input textures. Let's just get the compiler going and see what we print out. Probably, hopefully, just a bunch of gobbledygooky data. We got fast and file watch going. Just rebuild automatically for us as we make changes. A data word might be redundant. Okay. I think, what did I call it again? Wave function, no, I called it WFC test. WFC test. And that's going to be missing the image arg. Okay. Stack exec WFC dash test. And image is going to be data sprite 01.png. Okay. Input image must be square. So that's not... Hopefully our test image is actually square. We're gonna have to open our image editor. Yep. And apparently I have to update Steam in order to do that. Because I blotted through there. Yeah, like a moron. I should probably get a non-Steam licensed Sprite or see if I can get it off of there. Now that all that Steam stuff has changed. I don't know if they'll end up using that power, but the whole ability to the whole ability for them to just basically say, all your software is licensed now, we can take it away whenever we want. It is what it is, but hopefully they won't use it, but I don't trust it for all things. Games, whatever, but I don't know. Some software and they're like a Sprite I'd like to continue to have access to. Well, I don't want to show my Star Steam library. I just want to open a Sprite, thank you. There we go. La, 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 la. How do I, where's my picture? In home. There we go. Projects. Where's my projects? There. And in wave function collapse down here. Data. Wait, 001 PNG file. Okay. How big is this? What is the stats on this thing? Pretty sure I made it square. Properties. 12 by 12. Yeah, that should be square. Okay, maybe our detection code isn't super great here. Okay. So this is what we're getting here. Image width, image height. This should be 12 by 12 pixels, which means they should be equal. Even if it's 0 by 0 and like it's not loading anything, we shouldn't be hitting that unless we get like a really... Print those out though. See if we can get that to go. Yeah, 12, 12. Okay, so they should be equal. Oh. Ah. Dirt. They gotta be not equal. So we'll just, we can change this to unless, or... I don't know if I have less in scope. Maybe I have that in scope. I don't know. Yeah, I do. Well, I don't need window. Ba-bum-bum. Okay, run it again. There we go. Okay, sweet. We're rendering our texture now. I got some texture data. We got some data. We didn't... Well, we haven't really... Well, actually we are getting it, so we haven't really segfaulted. Cool. Cool, cool, cool. Awesome. Okay. Okay. So we don't actually really need to build accessors to get all the data out of there, because we're not really actually, how do you say, manipulating the pixel data, color data itself. We just need it to be in there so we can render it back out again. Okay, so that's kind of the input stuff is there. We could wrap this up into a function and make it kind of nice, but otherwise I think we're kind of good to go on that part. So why don't we do that? Just pop all this stuff out. Input texture will be like we'll call it from SDL. And pass in the image surface. The image thing from image load. I got a type error, hopefully. Oh, maybe not in editor for some reason. All right. So the type should be surface. Do IO texture a. We don't actually care about what the A's are, except maybe we kind of do later on. We're going to want them to be CU ints. I'll pop this in here. Give a binding for image. There, realign everything. There we go. Perfect. Hopefully that all compiles still. Good. I may have forgotten something. Return type. Yep. Wrong. Probably the wrong type. That's probably the STL texture it's trying to use as a type there. Well, that's going to be a WFC texture. That looks good. I'm going to rename that from SDL to be from surface. Yeah, and that looks good to go. I'll create a little committee commit. Stage that. Good. Add from surface. Boom. Sweet. What next? All right, so we got from surface, and we've got to next go to our to-do file. We're gonna get the texture back out once we run the thing. So we're gonna run the algorithm. We're gonna get an output texture. There might be some stuff to do internally to that, though, in the library, as I recall, in order to implement get texture. So if we go back in the library, we'll go into source, algorithm, wave function collapse here. When we run collapse wave, rerun the wave. We get a grid as the output. Oh, it's a new type. All right, which is an array of cells. So basically, we have to write this function. Has to go through this array of cells. Has to get all of the collapsed patterns and do all that kind of stuff in order to render to get the texture. We want to go from a grid to a texture, and then we can write our function on the outside that goes from our WFC texture to whatever surface graphics format you use, kind of thing. So a lot of just unwrapping type stuff. Okay, so first things first, let's go from our grid to our output texture. We got cell out. Let's put it right here next to our grid stuff. We'll call it from grid, big grid. We'll get a texture of A. Okay. So first thing we're gonna do is we're gonna get that array out. Or get cells. And then we want to do something with that. We want to get all, we want to basically map over that if we can. Data.array. Take the info array. It's foldable, so we can fold over it. It is functor, so we can map over it too. So what we want to get out of each cell is lapsed pattern index. We're going to need more than the grid. We're actually going to need the final wave state. Because having just the pattern, the wave state has all of the pattern indices that we need in order to do this. Adpex twin, what's going on? Are you an Aphex Twin fan by any chance? Nice. Window Lecker. It's the bat. Like, probably just such a great album. Such an achievement at the time, too. Okie dokie. Yeah, so that's going to be a problem. We're going to have to fix that. We can't just do it from the grid. Alright, so run wave, we're going to have to update that, not to just give us the grid. We actually need just the final wave state. We need the whole thing. Which makes this whole let binding kind of redundant. I'm not going to say the D word. I'm going to say the R one instead. Get rid of all that. I could even short this even more if I wanted to, because really you can go... Get rid of the wave, put this here, there, and then flip it around, and now it's point free, so we can get rid of the wave argument here. Whoa. Yeah. Yeah. Okay, so we pop back over here. We don't want necessarily from grid anymore. We want to get from wave state. Wave state, or take a wave state, and we want an output texture. It's going to be our output texture for rendering. Okay, so from the wave state, we still need the grid and do all the transformations we were about to do on the grid, but we also need the... Oh wait, actually, maybe I'm getting ahead of myself here. What's in grid? No, grid is just the array, yeah. So we still need... Where is it hidden? Is it hidden in... Is it put in frequency hints or GCD rules? Oh no. Basically, I need to know where I've stuffed those pattern indices so that I can go look them up. Adjacency rules. Okay, pattern indexes, pattern result. Okay, it's in the pattern result. Okay. Okay, I need that. Pattern index to int. No. Okay. So we got to do a little bit more work here to make sure that the state has the pattern results that we've generated everything with. So we're going to still tie some things together. So we get the pattern result from this patterns function. Okay, so, okay, so when you make the wave state, you have to make the pattern result. So we could just stuff it in there, or we can assume that because you've generated the pattern result, you're going to have your pattern list and you can pass it into our output here. Or we could just make sure that it gets stuffed in the wave state there, which is probably nicer. It's probably going to break all my test code, as it tends to do when I add fields to the wave state type. So let's go add that. Okay. I'm just going to make this undefined for a bit. And then I might have to go fix the test code and get it all compiling again. I'm going to make a little committee commit for that. And get back to where we were. Codex roll. Yeah, so the idea with that is that all of the patterns that get cut out of the input pattern. So I don't know if you've been watching from the beginning, so I'll just kind of give a high-level overview of it. And those for those tuning in for the first time and everything. The whole 9 yards as well. So you have like an input image pattern. Like a bunch of a texture of some kind, right? And it's like a grid of, we're just kind of imagining it as a grid of pixels. And the idea with it is that we create our, what's called the adjacency rules, like what pixels are allowed to be next to what pixels by cutting out little patterns from the pixels. And we cut out overlapping patterns. Okay. And then patterns that overlap are said to be allowed to be like adjacent to each other when we're creating the adjacency rules. That sort of thing. And because we reference those patterns quite a lot in the whole process of the algorithm, we basically keep just like we generate the map of the patterns once, and we just refer to them by their indices throughout the rest of the algorithm. If that makes sense. We generate like a mapping and for the adjacency rules, and we generate mapping for the frequency hints, like a bunch of other data that references the patterns, and they all reference the pattern by index. So the output grid in the cell data has just the pattern index that we like collapse everything to at the final, as the final result. And so we have to go back into the patterns in order to into that list of patterns by index and fetch them out by index. Then we got to fetch out those patterns. Once we get the patterns, this is the pattern data structure. And in order to generate the actual output pixel, we go into the pattern and we get the top left pixel back out of this array, basically. And then we have our output texture. So we're going to be working on that, getting that all hooked up. And then once we have the output texture, we can... I'm probably going to end up renaming that at some point because it's conflicting with namespace and SDL. So we have our own wave function collapse texture, which is just like a wrapper for some pixel data. And then we'll just have a translation function that'll just put that into like whatever graphics library texture you're using and display it in our little visualizer. That's my goal, just to see that it works visually. Okay, so that's the story there. Hopefully that explains everything. This is what I need to fix right now. Yeah, line 4 to 40. Here we go. Why? Oh, pattern result. Oh, so our wave state needs a. Ooh, ouch, ouch. That's maybe why I didn't put it in there. Okay, so I'm gonna have to avoid that just so that I can avoid putting a type parameter on wave state and mucking up all of this code. Well, in order to generate the wave state, you have to pass in the pattern result anyway, so the caller has a reference to it. Hey, Warren Reed, no thank you. You are banned and reported. Have a nice day. And gone. Okay. Target acquired, destroyed, and okay. So yeah, we can assume the caller already has a reference to the pattern result in their hands, and so they can pass it into us when trying to extract and build the output texture. So what I'll call this instead is like make output texture maybe. Okay, like this, yes. Okay. So we're gonna need two. Well, the first thing we're gonna need is all of the pattern indices from all the cells from the grid and the wave state. So we're gonna probably, I guess, bind that. And from those pattern indices, we're going to have to look up all the patterns. Or to do something. Well, we have to do something in there. Let's just get the pattern indices first. Okay, so we got to do something with the wave state grid. Okay. That's going to be get cells. Then we get an array. of int cell. So that's the array of all the cells in the grid. That's cool. Then we can fmap over that. So then we get the sorry, what's the type in there? Cell, right? Yeah. Field accessor. I'm just gonna put back there. Cell over here is collapsed. I don't like the maybe in there. That's gonna be really annoying. We might be able to get... Okay. Decision time. Essentially what we have here when we go to the cell is that we have, like, the array of cell possibilities. Now when a cell is collapsed, there should be only one, because we collapse it to that one. And during the calculation of the algorithm, if we get to a place where we try to collapse a cell beyond having one possibility, we would throw an error. I think I have a to-do actually to split this type out into collapse to two different types. I feel like that's what it wants to be. Because here, whether I use the maybes here. Let's say we just use the maybes and we use this cell collapsed here to pull up the maybe pattern index. This is just for every single cell when we go through the grid if the algorithm completed successfully. Right. However, because we could just collapse each of those down using some, like a function like cat maybes that concatenates all these maybes together and go, or whatever, to grab them all out and turn them into just values, basically. We still have to handle the case where like nothing appears. Like we could just ignore it, which would be hide bugs potentially, right? Or we could throw an error. We also have the arrays, and we know that when this algorithm is completed, this array should have exactly one member where this boolean here is true. And we run into the same issue, right? We could write a function that goes over those cell possibilities and get that one member. But then, like, maybe there isn't one. Or... well, there's also the other case you'd have to handle where maybe there's more than one, which would be bad. So I'm more apt to go to cell collapsed. I kind of want to refactor that out into two types, but I don't know how long that would take. And if that would distract from us getting close to the visualizer, and if it would be worth it. Let's just take a quick hack at it and get a feel and see what that would be like. And if it feels worth it, maybe we'll go down that route. Collapsed cell. All right, so this would be instead, this would just have collapsed cell pattern index. And that just be the pattern index there. We wouldn't need literally none of the other data. That's all just used by the algorithm at runtime. Alright, so it would even be just a new type. Now, our grid right has the cell here, so we'd actually want the ability to have like either a cell, meaning one that isn't collapsed yet, or the collapsed one. So we could wrap that into like don't know, like a type alias for either. Whether you either have on the left side a cell or you have a collapsed cell. Yeah. This would require quite a bit of rewriting to do, I think, because if we put this in here, I think we're going to get quite a lot of type errors. Aside from it not having some basic instances that we should have. Make grid, cell at 3, 4. Well, that's in progress stuff. 5. Quite a few places. Well, actually, about 6. It's actually not too bad. And then, if we went down this route, we would also be able to simplify our is collapse checking. It's collapsed at. Collapsed function would then be this would actually be our grid cell type. And we would just case match, pattern match on left or right, basically. I mean, there's fancier ways of doing it, but I don't think it'd be necessary really to pull them out. So this might be okay, actually. And that way, if we had this, then we would just be pulling out of the grid the collapsed cells, and we just have to detect if we pull out a non-collapsed cell, then we'd have to like do some kind of runtime error. We could have some checks in there for something for that. Yeah, let's go for it. Let's do it. Seems worth it. Then we get rid of this field and maybe another thing. Yeah. Okay. Let's just check on where my code is at, actually. Update here. Yeah, save the file. So I think I got some changes mixed together here. Okay, I'm gonna... Okay, how do I get the... I just want to pull that hunk out. Can I unstage it? Oh, okay. Can I just stage the individual hunks? Yes, sweet. Okay. Cool, cool, cool. We'll actually go in here. We'll just leave this undefined at the moment. Okay. Yep. Progress. Modify. On wave. To a wave state. Key, and then we can go back. We can take on our new little refactor here. Okay, so let's go over to type grid cell here. We'll pull that out. Go up to our collapsed cell. Pop that over here. I think we can actually get rid of this field too as part of this refactor. Just delete it. Because that information will now be in collapsed cell. It doesn't need to be in cell at one time anymore. Okay. Alright. So then we just fix the type errors. That's all we do. Just go one by one. So don't have that field anymore. Don't need it. Oh, look, there's another one. Okay, so check collapsed is going to be an area where we need to just get rid of it or change it if we use it elsewhere. But I think we only use it here. We probably use it in a few places. No, we don't. Interesting. Okay. So we don't need it. Let's get rid of it. Okay, so collapse cell now. We don't need to do all of this junk anymore. Right? Because if we're doing a collapsed cell now, collapsing the cell now, we don't actually need to provide a new cell where the possibilities are all updated and blah, blah, blah. We actually just need to produce a grid cell. And all this has to do, I don't think we even need the input cell to do it. Yeah, I don't think we even need this cell to do it. Let me just do it that. That. In fact, we don't even need the wave state. Why was it using the wave state before? Anyway? This is just a pure function now. Don't need the cell. Just need the pattern index. The grid cell, this just becomes, right, collapsed cell. Yeah, we can get rid of it. It's just the two constructors. Probably gets used up here. Yeah. So that just becomes this. And then we could even get rid of that from there. Here. Just set the grid cell there, the collapse cell there. Okay, cool. What's this problem here? Right, so pick pattern. Now it's to take a grid cell. We go pick pattern X and we get left. A cell, that would be fine. But if we get it right, a collapsed cell, in other words, that would be wrong. Do we have the index of it? No, just a cell. Yeah, it's been... Oh, I gotta put the thing that's around it. And pops around it. Is that it? Alright. Okay. Next. Okay, well the cell entropy has changed. Okay, let's see, how's this called? Cell entropy change cell and cell prime. This is in modify cell at. Okay, so modify cell at means we're going to be taking a grid cell now. Doing a get cell at, get cell at. Gotta change that as well. Probably, actually, this is going to start to turn into a little bit longer. Hopefully it's not going to be too much worse. Do grid cell. Cell at. Okay, and make cell. Just have to return grid cell, but it's going to be initialized all to left cell. Setting a cell, it's going to be grid cell. That's easy. Get cells. Grid cell, okay. Build entropy list is probably demanding that to be a cell. It is. Okay, so our build entropy list stuff. Okay, so this is starting to get a little hairy. Entropy cell. Float int int, that's not a problem there. It's the entropy calculation. Okay, that works for left cell. Oh, I don't need the permanent. Okay, works for these. But it doesn't work for the other type. Okay, remove pattern from cell. This makes a grid cell, returns grid cell. Okay, so that works only on our left case. Yeah, we have an error here. And we just say a collapsed cell. Okay, and then remove possibility, probably a similar deal. Anything else in the right case doesn't matter. Very similar pattern going on here. Oh, we got to wrap this back up on the left. Constructor. That's going to get a little confusing using our type alias here. I could see that being using a proper type for this might actually be better, have been the better choice. Get neighbor removals. Index state, wave state, list of removal patterns. Okay. Not enabled is probably causing this. Taking a cell. Yeah. Cannot handle lapsed cell. So a further refactor to this would be to get rid of the either. I think the either is a mistake. There's plenty of places here where we're just adding the error branch on the right when we match the right constructor of our thing, and that's, I think that's good largely because there's lots of places in this algorithm where we don't really care to handle collapsed cells. We want to generate them when they are collapsed and store them somewhere, but when we're running, during runtime, we actually only care about the cells. So I might do that as another pass here. Remove pattern. Problem with this one. What is the pattern with this one? Oh, it's modify cell ads. Yeah, grid cell. Look at that. Oh, that should be. Oh, it's cell entropy change. Yeah, because now we have another case here where if you want to modify a cell in the grid, you generally in this function you only want to modify an uncollapsed cell, right? A cell, not a collapsed cell. You don't want to consider a collapsed cell. So if you get a collapsed cell, like that would you just be like, why? No, this would be bad. So I think there's a chance here. Yeah, get cell at. Yeah, we go into the wave state grid and we just get that either out. Yeah, it's not too... Yeah. Okay, so, well, be that as it may. The problem with modify cell at here is that the cell entropy has changed. We only care about the cell entropy changed on an unmodified, non-collapsed cell. We only do that for non-collapsed cells. This technically has to return a grid cell callback. Actually, I suppose since that's already in an either, this could make sense to return just a cell. And that would be fine here. Because then the user's F could return an error here, and then we throw the error already. So like, if they were like, hey, I only want to modify cell, I don't want to modify collapsed cell, I can't do with anything with the collapsed cell, then you can return a left here, and then we'll modify cell that will throw a runtime error essentially, which is not great, but that's handled at least. So in the right case, cell entropy changed is here. And the problem is, 4 arguments what we've given by. Right, okay. Simple. Okay. Okay, and put cell at. Well, this one has to be a grid cell. It's not there. Probably got a few more. Okay, so put cell at in this case. Again, this is just a slightly confusing, but we should put it in the right structure here. Oh, sorry, left. I mean, it reads poorly, but like the type checker will catch you, so it's not that bad, but anyway. La la la. Oh, yeah, okay, so OG cell here is not a grid cell. Or at least we haven't proven that it is. So we could... we could discharge that with a function. What do we want to do here? Oh, this callback function, sorry. I'm obsessing over this a little bit here. This callback here is saying, like, for any grid cell you give me, I will either give you a string or a cell, which has the implication that you could give me... They're independent of each other. So you could give me a collapsed cell, and I could give you back a runtime cell, apparently, is what this is saying, which may not be right exactly. And it still might be the case here that we could go from the left to the left, or from the left to the right and the right to the left. Kind of cross things over and get things crossed. But at least we'd have a chance of handling both cases. I'm modifying both cases. Okay. So that's fine. That introduces this error here, where both of these argument types are now grid cells. Means put cell out is fine, but the arguments to cell entropy changed have to be handled. Now we can put these as grid cells as before. Grid cell. And then left. And then if we have write anything errors before. It doesn't matter what this type of the second one is at all, actually. Cell entropy changed. Tried changing entropy a collapsed cell. Okay. Okay, so neighbor cell is our grid cell type. Is contradiction. Probably just wants a cell. Which again, for right, doesn't apply. Does on the non-cross ones. Decrement. Neighbor enabler counts. Yeah, no, again only works on cells. Doesn't matter what the pattern index says, neighbor counts of the directions, but if we have a right, whatever. So this pattern's already telling me that maybe we want to, maybe we don't want the either in there. So it's doing all these runtime checking for types here. See, hopefully we're getting close now. Okay, so neighbor cell here. That only works if neighbor cell is a cell. So it feels like I want to make sure I actually not just get a grid cell app, but get a cell app. Yeah. Well, I get a cell at prime for a minute. Basically, I want this state, wave state, cell. Cell index. And I do all of this, except I have a left cell, then I return that. But if I have a right cell, or right anything, I also return an error. Well, perhaps I can actually like put a cell index there as well. And then if I do it like this, very cool. Is contradiction. Can actually go back to being normal, but we'll just pop that in there to get rid of that. Okay, this line here. Or I believe this is initializing the pattern, the stack of patterns to collapse the wave with. Which I don't think we... Actually, kind of... maybe we don't really need this. What is this saying? This expression here is taking the possible... What was the possible patterns of collapse itself? You know, I think what we replaced this with, when we collapsed cell originally was like a cell with all the possibilities reduced to just one. If I'm not mistaken. Collapse cell. Yeah. Yeah, so cell possibilities becomes collapse cell possibilities, pattern index for all the possibilities, and we set cell collapse to just pattern index. Okay. Yeah. So what that means is that in this expression here, we were going over all the cell possibilities of the possible all the possible patterns of the cell possibilities of the collapsed cell, which really is just one element. Then we're filtering to get just the pattern index we collapsed to, and we're mapping over that list by creating a remove pattern. What we really want is just to create a list with a single element, a singleton list of remove pattern. And we want the pattern index and the cell index. Hopefully our test will still pass. We may have to update the tests too. So now collapsed, like I was saying at the beginning of this refactor here, collapsed is just quite a bit different here. What would it be? It would be left. Cell would be false. Right would be true. Figure that. Okay. Fly check, at least in my editor, says there's no more errors. Let's go to my build output. I haven't checked that in a while. Okay. So we're compiling again. Hopefully, probably works, maybe. But I don't think my tests are going to. We'll get those working again. Oh. Oh, no. I didn't expect it to. Good. Okay. Hopefully not too many, though. 207, just some cell collapsed lines that need to be replaced. Okay, no problem. That. Get rid of that. Get rid of that. Okay, they're all gone. How we doing? Okay, a couple more. Dummy cell, dummy cell. cell just needs a left. That needs to be fixed. Domicile, more domiciles. I think those are good. And then I think we've got good old friend init wave state. That's failing at the moment. Okay. All those not enabled. Right, not enabled. Let's try not enabled. Takes a grid cell now. Okay. Well, this, for these not enabled ones, this is just going to throw errors if we ever make it a right, so we're just going to make it left. Okay, 120. Have any equal cells? They should probably just be lefts. Okay, I think that covers those ones. What do we got left now? The wave state thing. Just that one. Okay, good. Right, so we changed the type of run wave. So what we will do is we'll just rename this to result state wave state grid. And that should leave us just the one. Cool. Final state. Okay. Uh-oh. Okay. We went a little too far on the refactor here with something, and we broke it. I suspect it might be my assumption about the initialization of the collapsed cell and the stack there. That might be it. Oh wait, maybe. Maybe not. Hang on a second. Might have just been skimming this a little too fast. Get cell at in runway returns grid. Start with. Get cell at prime. Okay. Collapsed cell 3-1. Yeah. Might be that. Boom. No. Close it there. Okay, so we don't... Either we don't want get cell at prime here. We don't actually want this. Or it's the other, the initialization of the stack. That's the problem. Okay, so let's just try and deal with this here then. Okay, so this is... Okay, so enable accounts only works if the neighbor cell isn't collapsed. Quick hacky code here to just see if we can get this test to pass again. Will be a case match on the neighbor cell. Right, who says you can't write dirty, ugly code in Haskell? This is disgusting. Yeah, okay, we are getting there. I think we could still... Yeah, actually, if we change the type of get enabler count here, take the neighbor cell, it shouldn't return a number to compare against. And would 0 make sense if the cell is collapsed? I think so. I think 0 would still make sense. So, we use enabler counts anywhere else except for that condition. 0 counts. Okay, we do use it in a few places there. In this scope. We could return an enabler count for a collapsed neighbor cell. It would just be the empty one. So instead of case matching on it, let's just write a function for that. Call it get neighbor counts for neighbor cell, maybe? Is that allowed? Did I not define? I haven't defined that yet. Good. Take a grid cell, and we're going to return enabler counts for it. We have left cell, then we know we can just do cell enabler counts. And if we have get enabler counts for the right, here's where we're going to return the empty one. Sorry, cell pattern enabler counts. Pattern enabler count. What am I doing? I'm missing up something here. Okay, yeah, it was. Oh, okay. Compatible planner. So we need that parameter in there. So that's the expression we need. For the left case, okay, okay. So here, need a pattern index, a grid cell. So just pattern index. And then in the right case, we will get the empty one. And so if I make a pattern enabler count, this function here, direction 0000, that, I think that's the empty one. Okay, and then we have to pass that in here. Compatible pattern. Okay. Let's see, did we work? Ooh, interesting. Let's see, decremented enabler counts doesn't work on collapsed cells. Maybe that shouldn't be returning an error, actually. That's actually wrong. Because there would be nothing wrong with us returning just the collapsed enabler counts, because they don't change anyway. But that's going to be... the pattern match on that is going to block the other one from getting matched. Oh, let me try to change the entropy of the collapsed cell as well. Maybe we don't actually need to return an error there. We're just being a little bit too aggressive with those. Let's just say false. I think false kind of makes sense. This is not exhaustive, so let's put this to do. Now is it exhaustive? Yeah, we have a... Logically, I think that makes sense. That's kind of a little bit weird, though, this false case, actually. Because, like, there's... What it was telling us with the non-exhaustive pattern matches is that, like, we could have a case where we're trying to compare the cell entropy changed of a collapsed cell and an uncollapsed cell. That's totally legit by the type here. And we're not handling that. We're just saying the entropy hasn't changed. In that case. Even though in that case, that would be like, did it change? I don't know. But, however, our tests are passing. So there's that at least. Okay, which means our refactor is good so far. Stage those, create a little committee commit. Work in progress. Here we go. Refactor cell into grid cell. Adds collapsed cell type distinct from cell type. Adds grid cell type alias. to tie the two together. May not need grid cell. Cell is only used at runtime in the algorithm. And collapsed cell is the result. Might not need it. Maybe. I'm just emphasizing that because I think there might be a couple of cases where in propagation we actually do want to check. We do check for the right case. Perhaps if we want to deal with backtracking and all that stuff, which we don't currently. We just kind of go, contradiction. Okay, so there's that. Now, going back to the thing, we only got about 10 minutes left on the stream. Hopefully that'll be enough. So now with our output texture, we're going to go through the grid and we're just going to get those grid cells. We're going to check that they're right. In the left case, we're going to be like, what the heck? We haven't collapsed a cell. And that's wrong. So this texture, this would be either string or texture A, because we could potentially throw an error there. Okay, so we need the pattern indices. Right, from the get cells from the wave state dot wave state grid. We gotta do something with that. We're gonna do that good old left map. Okay, so that's got a grid cell type now. So in this case, we only want the collapsed cells. If we detect a case where there isn't one, we won't actually throw an either. So I don't think we want to F-map over these cells. I think we are going to fold over them, maybe with traversing. Well, we don't have applicative for array. Equals show or read interpolable. No. Okay. If we converted this to a list in order to get the applicative list instance on list in order to do this traversal, yeah, maybe. Yeah, it would work. We could make it work, but it'd be bad. Why would it be bad? We'd just be building up an intermediate list. Same size as the array. And then traversing over the list. Don't want that. But we should have traversable for the array, actually. So this should be fine. What's wrong? What's wrong? What's wrong? What's wrong, GHC? Am I not seeing the whole picture here? Grid hole, okay. Grid hole here wants grid cell F0 to B. Okay, okay. Okay, I'm not seeing the whole picture here. That's the problem. That's the problem. Okay. Doesn't know what F0 here is. That's okay. What's F0 supposed to be? I don't know. It's supposed to be, actually, we're going to be like an either here, right? So let's tell it that. Okay, so now it knows. Now it knows. Now GHC is cool. It's like, oh, okay. Alright, so I know what the results of the traverse should be, and either string B0 from a grid cell. Okay. So this function here, we're going to define as get collapsed. We'll just call it get collapsed. That sounds fine. Pattern. X. Right, and that's going to be grid cell to either string pattern index. And assuming the type is good, okay, so now in this hole, we should have in scope pattern indices. Okay, that's an array of pattern indexes. Okay, cool. And so now we can get those out of the pattern results using those pattern indices. Pattern results. That's up here. We're going to be indexing. Hopefully there's not a ton of patterns. Because we're going to be indexing into this list here in order to get those patterns out. We could probably convert that to an array. Gross for now, but we're just going to do it. It's not the worst thing in the world. Yet. Okay, so we could use the array indexing operation here, which is a partial function, which will throw like nasty errors on us. We know technically in our minds as programmers that these indices are going to be valid indices into that input list, because that input list can't be generated by the user. It's all generated internally and all that stuff. However, Haskell doesn't know that. So what we're just gonna do this. We're just gonna do it. It's gonna be fine. It'll be fine. It'll be totally fine. Patterns. Okay, so we got all the pattern indices from our wave state grid. What order are those in? Those are going to be, if we're traversing over the array, those are going to be in like row column order. So we actually have to know the output size of our texture, our dimensions. Which I think the grid has in our wave state in order to reconstruct the output texture. That's what I'm getting at here. With the patterns, we can get the patterns out, no problem. So let's get those out. We can traverse over that again, but we don't want to. But we'll rejigger the expressions here so that this will be a one. We can do this in one pass, I think. Okay, so if we traverse over something over the pattern indices again, what's the shape of this function? Pattern index to either string or 0, B0, whatever B is, which is going to be pattern. That's going to be get pattern, which is going to need the pattern results list. We'll just give it the pattern result. All right, and that's going to be a pattern result. A pattern index. And we have to return either string or pattern. All A's. We need the type. Okay, so now in our hole we should have in scope patterns, our array of patterns is good. And now we can start constructing our output texture from that. Boom, which we are definitely running out low on time for. Okay, so we might not be able to fill in all these holes. Let's try and get it to a somewhat of a point. Here. So let's go raise my seat up a bit. Well, hopefully I wasn't too far back from the mic. You can still hear me this whole time. Sorry. I'm good at this, I promise. All right. So texture. That's a fill from list, not quite. Okay, so our texture, our output texture is also going to be... Now, I don't know if this is true about wave function collapse in general. I feel like the output texture doesn't have to be square, even though the input texture is. I feel like the output texture should be able to be rectangular if you wanted it to be. However, this one is same size. Grid. Let's check grid. Okay, so we could get the dimensions of the array in order to get the size for our output grid. Sorry, for our output texture. Technically, under the hood, it's an array anyway, as well, so that should be a pretty straightforward transformation. We just need to get the top left, have a function to get the top left pixel of our pattern into our patterns array. We put the texture constructor around that, and then we're bueno. Okay, so that's that. We've got patterns, array int. We could convert that into a word in order to construct a texture. Somehow. Not quite there. Ooh. Is there a way data.array to map over the index type? Xmap. There we go. Allows for transformation on array indices. So Xmap would allow us to go, give us an I guess a lower and upper bound for I. Mapping function from I to J. An input array J and an output array I. So our mapping function here would be to go from int to word. And this would be the bounds of our input array. So Xmap might be a way we could do that. Might have to do something after that. Not in scope. Prefix it there. Xmap needs more arguments. So the bounds is going to be that one, and our function here is going to be word to word. So array to get the II bounds function of patterns. This hole here should just be int. No, 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 no. That's not right. Okay, let's leave that out for a second. Let's just get this hole here. Ah, okay. Okay, so we're... expecting int word here, because we're passing in array J here, and J is, at least in patterns, int. It's thinking word to int. Why shouldn't it? Pattern should be int, and I'm in my head I'm substituting I for int here, but oh, a J. So it wants I to be word. Word to int? Yeah. Okay, I'm getting stream brain. There should be simple substitutions here. Okay, so clearly it's thinking I is, it wants it to be word. Okay. And we're giving it J. Okay, I got it now. So patterns is int, J is int. Okay. So what I need to do is take that. It's the same bounds as patterns, but I have to express it in word, basically. As word. So let me let bind bounds. Because you can't, over tuple, I don't think you can F map over that, only it's like the one element. We type bimap. I have bifunctor in scope. Yeah, so maybe that'll work. Gross, something like that. Is that happy? Not quite. What am I doing here? Xmap is doing something with my return type? Or you just don't know the type, the return. Okay, maybe I gotta fill in. Type apply for E. Or maybe if I put the hole in here. Okay, that would be fine. And then we just got this one. Okay, you still are upset with me. Because we... I'm not expecting a pattern of A's. TypeScript doesn't have type holes. I'm not surprised. Is there a package for it? Well, you're right. I wish they actually had type holes, but they can be kind of simulated according to this blog post. Maybe. I just kind of want to get through this so we can call it and finish this expression here. So we're almost there. Okay, yeah, from integral isn't going to work on that because I'm being quick and dirty here. Let's go to Hugel. Can we go from an int to a word? In base, maybe? To enum? Not quite. Let's see, what else could you do? The problem going from int to word is that word is only positive. All the negative ones wouldn't make any sense. I don't think the abs function would provide enough proof that we remove the sign, and would be a conversion to whatever. Because it's a, yeah, using int for array. We know that the dimensions of the array would not be negative, like that wouldn't make sense, so using int is like mer. Why am I using int in these arrays? Probably for convenience. The cell locations. Yeah. Yeah, we could turn that into words all around at some point. But basically we would need some kind of conversion function from integer to whatever. It says 2enum would fit. Dirty, gross, hacky code. Let's not leave that in there. Okay, this hole here, though, now just needs to be array of some index of pattern A to array word of A. And that would be our, what does array have again? Foldable. Yeah, we have foldable. And pattern A here. So then this is our top left pixel function. I'll get pattern pixel. That'll be pattern A to A. If I can type A, there we go. There. Not the extra T though. Okay. Oh, what do we got here? Oh, yeah. Boom, boom. Arg. Okay, bounds and patterns is not the right dimensions, is what it's telling us here. Or is it? Patterns. Patterns. Yeah, it should be the right dimensions. Ah. Ah. Aha. Okay. Ooh. Two word bounds. I'm gonna define it, but I'm not gonna define it. I'm just gonna put it in there. And that's gonna be the lower bounds for the upper bounds because it's a two-dimensional array. There we go. And then we got a cast, basically like a casting operation here. You know what I'm saying? Word. Okay. In one part of my code, I'm like super smart. In the other part of the code, I'm not. Yeah, I gotta make them work together. Convert their indices. Okay. And if I can write that, then that type checks. And then this is not necessarily... data bifunctor. It compiles, sort of. Maybe. It compiles. Okay. We got a little bit of work here to do still, but I am running out of time, so I'm gonna have to call it here. Let's look at our code and get all this going. Okay. Quick little review. Looking okay. Yeah, this is like work in progress still. Very work in progress. Add make output texture. Okay. That one can stand on its own. Let's rebase all of this. Just gonna reword that one. I think all of these can actually stand on its own. I think I just want to reword them to get rid of the work in progress part, except for you, but Yeah, I'm gonna go with that. I'm gonna go with this way. I'm just gonna get rid of that. Okay, I'm gonna push this up. Bam, bam. So, if this is your first time watching, welcome. Thank you for watching and following along and hanging out with me. All the code you've seen tonight is up on GitHub. I'm Agent Ultra there on the Fediverse, on Twitch, and various other places. This has been Wave Function Collapse, and this is where the code is. So if you want to follow along, you can give that a little star, whatever. Do what you want to do, fork. It's all good. It's just learning code. And yeah, there you go. So following me on the socials, I'm on the Fediverse on the types.pl server. I'm Agent Ultra there. You've got basically links to all my socials at that place. So if you want to follow my VODs, go back and look. I back up all my VODs on my YouTube channel. There's a link to my YouTube channel, my website, and all that stuff. And I post updates about streaming and things like that, as well as other little bits about programming and whatnot for the most part. So you can check that out there and get notified of the stream. I usually do this stream on Tuesday evenings at about 10 after 8 in the evening, the Eastern time zone. So if you want to just write that down in your calendar, or if you're like cool and hip and stuff and you want to like, you know, give a follow here on Twitch, or, you know, hit that subscribe button, hit the like button, and on the YouTube side of things. Let's see. You can also go above my head to this link, discord.tv. Cool little website there. And there's a Discord server link there that also goes to the Discord server where we have a channel for this stream. So if you wanted to ask questions, you're watching a different time zone, you're catching about old VODs, whatever the case may be, I'm usually hanging out in there. You can ask questions there and also find other cool streamers doing stuff in Haskell and other declarative style languages, functional programming languages, the whole 9 yards. And that's all I got for you tonight. So thanks again for following along and hanging out. My name's Agent Ultra. May your monads be free and your types always check. Happy hacking out there. And we'll see you next week. Take care.